You guys, you took 600 seconds. Who was counting? Weren't you the guy? I was sure I told you to ring a bell when it was 4 minutes. No. You took that extra time. That's okay. Someone had a really good question, and it was your legend representatives. Woohoo! So, well done for picking them. You picked a good bunch. They're now getting stuff set up for you guys to use for your testing. Please help them in every way you can, because they're sort of going to be relying on you to come up with good ideas and to make sensible comments early on, rather than waiting till the very last week and then criticising everything. That won't be helpful. Now, what was your question? What's your name? Josh. Josh is, can I paraphrase your question and you just shake your head if it's not right? For the lock problem, we want our solution to be as simple as possible. Surely you could mount one argument that says just having a lock and not having wheels is in a sense simpler than having all these different classes of locks and wheels. So maybe we should go with the other one because it might be simpler. And I would say that is a very good question. And that cuts right to the heart of it. I would say if it is indeed simpler to do it all in one, then do it all in one. And if it is simpler to split it up, we'll split it up. And it's very hard when you start programming to get a sense about which way is going to turn out to be easier. My experience over the years has been that the closer you make the problem the code represent the actual problem, the simpler everything becomes. And breaking things into small parts turns out to be much simpler than having one big part. They're just my general trends and my general design principles, but they're not always the case. And I remember one year we were doing an assignment, I think it was task Ein, and I had mine broken down a little bit more than someone else did, and the tutor was telling me about their student's code, and I said, no, that won't be any good. And they said, no, it looks pretty good. And I said, no, they haven't broken it down enough. And the tutor said, well, actually, it looks pretty good. And I said, oh, show it to me, but it won't be. Oh. And lo and behold, they were right. So sometimes breaking it down too much is too complex as well. So what we're doing for task 2 is we're releasing everyone's task 2, so everyone can see everyone's task 2. And I've written one, and Rupert's written one, and Thurston's written one, and we're releasing all of those as well. So rather than me prattling on about what's simpler and what's not, just look at them all and decide for yourself what's simpler. That's ultimately, you're going to be the designers. You're going to do what you think is simplest. So yeah. Now I did want to talk about design principles. No, I don't think we've got time to do that. Instead, I'm going to talk briefly about exceptions, and I wanted to show you my lock. I wanted to show you my lock code, which I Java docked. But actually, I'm going to put that up on the wiki, and you can look at that, because it's Java docked, it's HTML, it's beautiful, so you can check it out yourself. So we'll put mine up, and everyone else's up, and everything's all right. Okay. Because I did want to show you 2 really important things that you'll need for design task 3, or that will help you a lot for design task 3. One is something called exceptions, and the other one is just talking about the actual tracking you're going to have to do to work out how to make a sound thing work. So let me talk about exceptions first. The first time I encountered exceptions was in a beautiful but very complex language called Ada, that everyone had thought of every feature that would ever be nice in a language, and they'd thrown it all into the one language. And I was amazed because exceptions were so nice. Here's what an exception is. An exception is, normally programs work absolutely fine and everything goes like you think it will, but sometimes something crazy happens. What do you do when something crazy happens? Essentially, you can either be really academic and decide I'll just ignore it and I'll assume nothing crazy will happen. If something crazy happens, everything will explode and whatever. Or you can write a whole lot of preventative code inside where you're constantly double checking everything and making sure everything's working like it's supposed to be doing. And you clutter up your program logic with a whole lot of error detecting and correcting and preventing logic. And that's no good either, because that makes a mess. And exception handling sort of lives between the two. It's this clever idea. It says, well, okay, let's just say we know there are going to be problems, and when there's a problem, we'll call it an exception. An example of an exception is someone does a division and they divide by 0. And as you probably know, as soon as you ask your chip to divide by 0, it actually starts to melt. And the whole system goes into a panic, and it's just this complete nightmare. And I think probably that's because computer chips were designed by mathematicians, and that's how they'd like the world to be. Because for them, that's a really important thing to happen. So if you ever ask your program to divide by 0, everything just is boom, that's the end. That's a serious exception. Well, you could constantly check that it wasn't 0 just before you did the division, and if it was, print an error message saying please enter it again because it's looking like 0, or I used 1 instead of 0, I hope that was right because 0 wouldn't have worked, so I've just gone with 1 and we're ploughing on, hope you can read this message somehow. But instead what exceptions do is they say, We're now entering an area of exception, where exceptions might happen. If, as long as we're in this area, any exception happens, please jump immediately to this spot at the end and do what I call the exception handler. Fix things up. And then you write all your code, and then you say, we've finished that area now of exceptions. And then you say, here's what you execute if an exception happens in that area. And then after executing that, everything proceeds as it was before. So you now actually have the ability to catch exceptions when they happen. And instead of the system shutting down, it jumps to a subroutine that you've written that does whatever you want, and then program flow continues. So it actually behaves a lot like a goto. And in fact, gotos, although we traditionally poo-poo them, are seen as a really neat way of dealing with exceptions. So most languages have some sort of goto-like facility for dealing with exceptions, and Java's no exception. Okay, so let's just think. If you did a divide by 0, what would you do? How would you handle that exception? I think the answer is you can't know. It depends on the program. If it's the space shuttle or something like that, the computer turning off or the program aborting is just not an option. No matter what's going on, you really don't want that to happen. So probably you try and fix it up as best you can, and then you just soldier on. And if it's some sort of machine that's about to cut into someone's heart to do brain surgery and something goes wrong, you probably at that time just want to withdraw the knife from the system. And if it's some sort of networking database sort of system and something's gone crazy, you probably want to shut all the files neatly, close all the USB drives attached, shut everything down, a graceful exit rather than aborting and everything being lost. Save everything you possibly can, all that sort of stuff. So how you deal with it sort of depends on the problem you've got and the scenario you're in. But as a mechanism, it's pretty awesome. So let me show you how it works in Java. It's very, very simple. We've got an immutable blackboard. Here we go. Here we go. Throw it away, get a new one. That's right. That's right. If you don't know what to do when an exception arises, you can just do nothing. This is like in a big bureaucracy. Like, for example, whenever I submit any forms to the uni, any things I don't like in the things I'm signing, I just cross out. So I give the uni all intellectual property in anything I do and anything I've ever done and anything I ever will do and anything my children do. I think, that doesn't seem reasonable. Cross it out. And then when I hand the form in to the underling at the form accepting desk, the underling looks at it. 9 times out of 10 they go, thank you, and that's it. Woo! But 1 time out of 10 they notice that I've crossed it out. And they go, oh no! You've changed the form! You're not allowed to do that! Oh, I did! Oh! Now, they can't deal with that. It's an exception. There's no rule in their thing for how to deal with it. They have no mechanism for fixing that problem. So what they do is they say, I can't handle that. So what do? I'm going to call the supervisor. They call the supervisor. And the supervisor goes, I don't know what to do. I'm going to call it, and they call it, and they just pass it up the chain. And that's what you can do with exceptions. Either you handle it locally, or if you don't know what to do, you pass the exception on, and then someone else has to grab it and do something with it. So here's what we do. We say try, squiggly brackets, end of squiggly brackets. And everything in here now, if an exception happens, we don't care. As soon as the exception happens, we're going to jump to catch. This is going to say what he's going to catch, squiggly brackets. And he says here what sorts of exceptions he's going to catch. And he'll say, for example, the most general thing is just exception. Because all the other special exceptions are subclasses of exception. Does that make sense? So you can have special exceptions like, I'm going to say divide by 0, but I think that's an error, not an exception. Invalid argument exception is a subclass of exception. So if this guy can catch exception, it can catch all exception subclasses as well. So I'll say exception E. And that means at any instant, if there's a problem, Java because Java loves objects, it generates an object called E that's of the class exception, and it passes it into this. And this is like now a function for the catch. So the function here goes, I've got to deal with the problem, and the problem is summarized by object E that's been passed to me by the system, a description of the thing. And what am I going to do? Well, normally, what I just do is I just go, oh, well, okay, system.out.println spot number 42 plus E. And what that does is it prints out 42 and I know, oh, it's that line that threw that exception. It's pretty hopeless, isn't it? I should do more fancy things. And then it prints out E. Plus E, what does plus E mean? Well, it converts E to a string and concatenates it onto that. How would it convert an exception to a string? I don't know, it's an object. It's got to have a way of doing it. And it turns out when it converts it to a string, it says all sorts of nice information in the string about what the exception was and things like that. So that works out reasonably well. And if you wanted to find more information, you could go and look up exception. Now, I haven't said what package exception's in, so what package is it in? Must be in java.lang. Yeah, so you could go to java.lang.exception. You could look up all the other things you can do with these to find out what things you can do with exceptions. Okay, so this code here, if anything goes wrong up here, instantly execution will jump down to here, execute these lines, and then the code will actually continue. And if I don't want it to continue, I'm going to have to put some sort of abort in here to abort the whole program. Or if I don't put a catch here, if I have an exception that's not caught, maybe I don't even put a try in, I don't have a try catch, I just have a few lines of code, and they throw an exception, and my function has no way of dealing with that exception because I haven't written a handler, then what happens? Who gets past the exception? E. Whoever called this. And you've got to hope that happened inside a try-catch block. And if they can't, if it didn't, and they can't handle it, they pass it to whoever called them. And if they didn't, they'll pass it to whoever called them. And what happens if it gets past to the very top? The buck stops here guy, and he can't handle it. He can't handle the truth. Yeah, those Java errors. Well, no, actually, it will never happen because the compiler is pretty obsessive about checking change of responsibility. So it'll say, hang on, you're here converting a string to a number. And there's a possibility that someone's not going to type a number into that string. They're going to type gibberish, and that's going to throw an exception. And you're not handling that exception. And I've checked. The person that calls you doesn't handle that exception. And I've checked. The person that calls them doesn't handle that exception. I'm sorry, that's not good enough. You're going to have to rewrite your program. I'm not compiling it. So it's pretty good at actually checking that you've either caught the exception or you've thrown it up to someone else. And if your function doesn't deal with an exception but can propagate it up, you actually have to explicitly say that. If my function's called, I don't know, find name, void find name, and the code in find name might throw an exception, Java, the compiler will actually say, Richard, you've either got to catch it or you've got to say throws exception. I've actually got to list the exceptions it could throw. Yep.
You forgot rethrow.
Rethrow. Oh, I could rethrow it. Oh, yeah. There's all sorts of fancy things you can do down here. Yeah. Yeah. But we're not going to go there. But that's right. Jared's right. There's lots of fancy things you can do with exceptions. But here's a rough outline of it. The reason I'm telling you that is to do this week's task, you're going to have to read something in from a file. Oh, man, there's just exception heaven as soon as you do that. Because you might give them a file name or the name to open. That file might not be there. Exception. Or it might be that you open that file and you say, read that in, it's a WAV file. And it might be not a WAV file. Exception. It might be a corrupted file. And you say, read 100 bytes out of that file. I'm expecting 100 bytes. There's only 98. Exception. So you're just reading and writing. Things are going to go wrong all over the place. So things are going to throw exceptions. So you're going to have to put try-catch blocks in. And if you're like me, because this is just a temporary testing environment, you just try it, catch it, and when you get an exception, you just print it out so you can see what the heck's going on. That's all you do to deal with them. Yep, because we're not actually operating on someone's brain in this particular case. All right, is that cool? So everyone understands exception and knows where to go to read more about exceptions? Yep, because you can ask a question because I've just looked at the clock, we've got time. Yeah.
So exceptions are when it tries to do something it can't, but what
Yes.
if it's more of a logic exception, whereas if you're asking a user for, let's say, an input,
Yes.
when they valid inputs in the context of the program would just say be the letters A, B, C, or D, and they don't put in any of those letters, and you just had like an if statement. Is that an exception, or is that just going to fall through?
That's a very good question. What's your name? Hayden. Hayden's raised a really good question. Can I just say, just before answering that, in the context of this is, did you notice I said before, exceptions give you a way of doing a goto? So if you're not the world's cleanest programmer, you might start thinking, oh, I can have goto. I'll use exceptions, not for real exceptions, just for go-tos. So what Hayden's saying is, what if you're writing a program and the person has to enter U for up or D for down, and they press F for finish? Is that an exception? Well, you could write it to be an exception, and you could throw an exception, you'd raise an exception, and then the exception mechanism would kick in. And I've seen some people do that as a coding technique, and it saves a few lines of code and things like that. But my own thought is that's probably not an exception. That's probably something that is well within your control to deal with in the program logic. And program logic dealing with user input is quite different to the program logic we normally write in this course, isn't it? But when you write that sort of stuff, UI stuff, it really is up to you to write something that gracefully handles all possible inputs and deals with them. So I wouldn't be tempted to use the exception mechanism for that, because you're in complete control of that thing. You're throwing the exception, then catching it yourself. I'd rather handle it inside the programming logic and just use exceptions for things that I have no control over, like you pass me a file, but it's an image, not a sound file. I have no control over that. So I have to panic at that point. There's nothing I can do. But if I'm asking you to type a letter and you type the wrong one, presumably I can ask you to type another one. So you could do it, but I'd think very carefully, is my take on it. And there was a hand here.
Yeah. When I did 2911, for my project, I had this horrible design. I eventually refactored it, but there was one point where I actually needed to use a goto in order to redirect control flow, and so I made an exception called goto exception.
Goto exception. At least you were honest. Yeah. So Liam's saying the same thing. He had an icky design. He wanted to have a goto because that would just solve that problem, but start another one. And so he made a goto exception. And full marks for calling it a goto exception. That's good. Yeah. And what were you going to say? Something. Okay. So that was a really good question, Hayden. I'm glad we stopped and you asked that question. That was excellent. So the last thing I want to talk about is Java, the design task. Design 3. And woohoo, for once we're actually going to finish everything in the lecture on time because we have like 2 minutes. So let's have a look. The design task is to, let's just go to it and have a look at it. Yes, let's, not go to. Who said go to? Here's the task. All right, now the important thing to notice is not hermit crabs. I'm prepared to predict that was Thurston. Did anyone check? Was that Thurston? It was Thurston. Thurston's job is to go through and scatter surrealism throughout the course. And actually, it makes me really happy and stressed when I really need something and I find hermit crabs. But, afterwards I think, man, that was a good course. I liked all those hermit crabs. And potatoes and stuff like that. Okay, the important thing to notice here is Java's got a tutorial that you can follow there that tells you how to use a sample package to do sound. Let's just jump to the part of it we want, which is reading and writing sound files. Blah 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 is my approach to all that. Let me see some code I can steal here. Now this is very, very yucky, messy, confusing code. So I'm apologising in advance. But this code here, if you look at it and skip all the bits you don't need because it's doing all sorts of things you don't need to do it, reading a small amount at a time and constantly rereading it and repeating it and things like that. And it's only setting up a small buffer. And when I wrote my code, I don't know about anyone else. How did you do with yours? I just set up a huge buffer.
You can't set it up to be as big as you want.
Oh, no, you can't make it as big as you want, but I made it like 10 meg or 100 meg or something, and all the sound files were smaller than that, and it all just worked.
It's like an issue with processing longs.
Yeah, that's right. Yeah, you can't go outside the range, it's a pain. But so I just made a big file. Is that what you did? You just made a big file and read it in. So rather than, okay. So you just make a big buffer, read everything from the thing, whack it in the big buffer, and then you just got to reverse it. It reads it in as bytes and stores it in this array. So I took that code and gutted it, and this is the important line here. There's an array of bytes called audio bytes, and it contains all the bytes for the program. And reading up about sound and all the blah, blah, blahs, I found that the sound file was made of a series of samples, and they were played chronologically. And each sample, in the WAV file I was looking at least, and this code here tells you how to find this number out, in the WAV file I was looking at, each sample was 4 bytes long. So what that told me is if I wanted to reverse the order, I had to get all those 4-byte chunks and write them backwards. But I couldn't just write all the bytes backwards, because then I'd be reversing each sample, if that makes sense. I need to take 4-byte chunk from the end, put that 4 bytes at the beginning. Next 4 bytes from the end, put that 4 bytes at the beginning. But within each of the 4 bytes, they're in the same order that they were originally, but I've just reordered the samples. Okay, so that seemed fairly simple. This got it all into an array, and I just had to reverse the array, and that just took a loop or something, and then it was all reversed, and I was happy as could be. But then I had to print the thing out, write it back out as a sound file. And this is where it got a bit tricky. So I thought, okay, I'm going to look at how you write it out. It says, writing sound files, that sounds good. Oh, and look, it's so small compared to the other disgusting one. And it turns out I don't need 9 of these lines, or most of these lines. The important line is here, where it says, let's just dim it down a little bit. Audio system.write, blah. That creates an audio file. Audio system starts with a K, so what is it? It's either a class or an object. It turns out I don't have, oh well, it's actually a class, isn't it? I don't have an audio system object. So there's a class called audio system that I had to then go and look up in the Java documentation to find out what the heck an audio system is. And it's got a write function that seems to create a file and do all the work for me. And I thought, woohoo, I don't have to do anything, except the annoying thing was this writing took an audio input stream, a file type and the name of the file object I'm sending it to. So these guys were easy, just using the code above. But what the heck was an audio input stream? So this is when I went into Java Dockland. I went to Google. Oh no, I didn't. I went Google and I said Java documentation audio input stream. And, oh, it showed me the version 6 one. That's really good. Here's an audio input stream. And the function was called what? It was called write. So I whizzed down to look for the write function. Where is it? Oh, no, it wasn't an audio input stream? Oh, audio input stream was a type. Where did this come from? Audio system. Oh, sorry, I'm one wrong. So the write function belonged to audio system. So I had to look for audio system.html. Let's start at the top. Here's the audio system. Where is it? It's in java.lang. It's in what package? javax.sound.sampled. So I had to say import, if I wanted to get hold of this, javax.sound.sampled.star to get all the stuff. And that would give me an audio system. And I wanted to use the write function, so I whiz down. Oh, there's write. There's 2 ways of writing a file, and they both take audio input streams. I thought, well, I don't have an audio input stream. I've got an array of bytes. Don't you have something that creates a file out of an array of bytes? And this is where you always are with Java. I've got this. You want that? Yeah! And then you find this chain of things that converts from one to the other. It's like Lego. So you go, okay, all right, you want an audio input stream. I don't have an audio input stream. Maybe I'll make one. So you take a deep breath. I'm going to make an audio input stream. I hope I can make it out of bytes. So I click on audio input streams. I look at their constructors. How do I make it? I either make them out of an input stream or a target data line. Well, I started reading about target data lines and they depressed me. It was very, very complicated. So I thought, okay, all right, I'm going to make it out of an input stream. How do I get an input stream? So I clicked on input stream. Class input stream. And then I saw something exciting. It has some subclasses. What are the subclasses of audio input stream? Byte array input stream. I thought that sounds so promising. So if byte array input stream is a subclass of input stream, that means this thing that's expecting an input stream would be quite happy if I gave it a byte array input stream, because it's a subclass. So now I've just got to make a byte array input stream. So how do I make a byte array input stream? Well, I better look up byte array input stream. Where the constructors, and I saw you can make one out of an array of bytes. And that's what I had. Woohoo! So that's the secret to Java programming. I'll see you on Tuesday. Don't forget the video on Thursday. Okay, see you guys.